Welcome to another part of group technology for the course of computer integrated manufacturing. After attending this session or listening this session, student or listener will able to understand how the part are classified and grouped together, and how and what are the various method for the part coding. So let's start. First of all, before proceeding to part classification and their detail, one may have to question in their mind, or in his mind, that why we need the part classification, why we need to go for a group technology, and what kind of things and what kind of attributes are responsible for that. So we must have an idea about the part or a design engineer who has to draw a new part, create a new part, and create any process plan so that a library could be created. So if the company is following already a group technology, so a designer can easily retrieve the earlier designs or designs available in their system, similar to what I need to make or what he should have to make a new design, so that he can easily use the existing design, change the existing design, and come up with a new design. So design retrieval process is much less time consuming than the part designing from the scratch. Second one is the automated part process planning. If process planning is already exist in the factory or any company, the part or process that already exist for any product should be all fetch or should be called for a new part, so that again process planner should have to go for a small kind of changes, and whatever he or she required the changes, and prepared a process plan much faster than the making the process from plan from the start. Another, with the help of group technology or making the part families, one can easily design the what kind of machine cell should be. The machine cell, whatever, are capable of producing all member of particular part family, so that the process could be faster. So here the three type of part classification we will going to deal. First, based on the design attribute or parameter, whatever kind of object we need to segregate, and we have to make it as a part of part family. So the attributes that are belongs to design, we will consider and we will collect the design parameter, and based on design parameter we are going to make the part family. Further, on the basis of manufacturing attribute, what kind of manufacturing process are involved, so we can make a part family on the basis of similar kind of manufacturing process. Third one, create a part family with similar codes. Already factory or companies following a code process system, या code part code system, या structure. So we will fetch, or we will collect, or we will retrieve the already available codes and match with the new one codes, so that we can segregate, or we can create a part family according to a similar code. Uh, Regarding the design and manufacturing process or manufacturing attributes, so what kind of design attribute should we look at? First of all, the basic external shape of the part, internal shape of the part, length to diameter ratio, what kind of material of the part, then what kind of part function is there, the major dimension, minor dimension, tolerance available, and surface finish. These are the parts attribute. On the basis of that, the part are going to be segregate. Similar kind of part are going to be segregate and prepared a part family. Now, second one is the part family based on manufacturing attribute. So again, the major kind of processes, what kind of processes are involved, and minor also. The major dimension, then again the ratio of length and diameter, surface finish, what kind of machine tools are involved into that process to making the part, then operation sequence, production time required to prepare a part, batch size, small, large, very large, then annual production required, then fixture needed in the manufacturing process, and various machines and cutting tools required to prepare a part. Here you can observe that there is a similar kind of attributes are there, like length and ratio, length to diameter ratio, then it may be surface finish, it may be major minor dimensions. So some dimension or some attributes are similar in a design and manufacturing attributes. If both are same, one may have to take the decision on the basis of correct kind of attribute, on the basis of correct whatever are major fraction and major kind of dimension or attributes are lying in the which section, that is design or manufacturing section. Let's have a example on this so we can understand easily the things. So here is the example of part classification. In this figure, the both part are look like similar, identical shape of the part. The part 1 required 1 lakh items per year. The part 2 require only 100 items. The tolerance is different for part 1 and part 2, and the material is also different for a part 1 and part 2. Here, based on the shape, we cannot say that this is belongs to similar part family. The process to manufacture part 2 item would be different than the part 1. In this figure, second figure, taking the example of in this various kind of object are shown. Here the objects are very different in a shape, but the manufacturing process required to prepare these parts all are similar. All are similar. For example, all parts here have first manufacturing process is the casting. Then they have to move towards the machine section. Then in machine section, the process on the machine tool may be lathe, milling, drilling, shaper. So these sequence are same in all these parts. So that we can say that the manufacturing process requirement are similar, but design attributes are very different because of the size to length to ratio, major dimension, minor dimension, tolerances, all are different, but process remains same. So with this example, we can understand that the part look like a similar in a shape, could have a different manufacturing requirement, and part look like a different, similar design, but having a similar manufacturing process. So the coding system is divided into system based on past design attribute used for design retrieval and to promote design standardization. So manufacturing attributes, so computer aided process, tool design, and other production related function could be accomplished at a good level. Then combination of both this. the combination of functions and advantage of these two into a single classification scheme, that is very beneficial. And I must say that the combination of hybrid of a design attribute and manufacturing attribute type of part coding system are more pronounced and more famous in the manufacturing companies. So major chunk of the company are following the design and manufacturing attribute hybridization. So now how one can code the part. So first of all, a part coding system consists of a sequence of symbol that identify the part design or manufacturing attribute. We are going to we are going to assign a number to a certain part so that the from the that digits, that numbers, we can easily identify that the part is belong to which kind of design attribute and which kind of manufacturing attributes. So the code may be all numeric, maybe all alphabetic, or maybe combination of both these. The most common classification of coding system is number digits. Number digits. Here I have shown few example of daily routine life items which are very useful in our daily routine life. For example, the Bonvita. Uh, have you ever gone through the kind of coding of that in that item already available on the pack of a Bonvita, or maybe this chips, maybe any juice or any book. So here you can observe that there is some barcodes. There is a barcodes like in a packet of a chips, packet of a juice, and of course the on the back cover of the any books. So this is how the barcode is there, and now onwards the barcode has been replaced with a QR code. Earlier the QR code was coarse, and nowadays you can see with this figure the QR code is evolving to a minor one, yeah, or precise one. So based on this, look at this number, look at this number. With this number you can fetch all the detail of concerned product. Look at this number. The barcode is a barcode and the QR code belongs to a product, specific product. So the product, their batch size, their manufacturing date, and so on. This kind of information is available with this kind of only the graphical codes. So this is the example that belongs to daily routine life product. Similarly, we are also assigning a part code to part that are going to or that which is going to manufacture in our factory. So here the part coding system consists of, as already I told, symbols based on the design and manufacturing attributes. The symbol could be all numeric, all alphabetic, or a combination of both this. Based on however, the most common classification code use the number digit only. There are three basic code structure are there. First is hierarchical, second is chain type, and third one is the hybrid of hierarchical and chain type. So hybrid will collect the benefits of these two and prepare a new one. So therefore this one is the more pronounced in the manufacturing companies. Here is the first one code structure is the hierarchical one. The structure of hierarchical kind of coding system also refers as monocode and is like a tree in which each symbol amplify the information provided in the previous digit. एक के बाद एक इंफॉर्मेशन हमें मिलती रहेगी. फॉर एग्जाम्पल, जैसा कि इस फिगर में दिखाया गया है, एक स्पर गियर है. The spur gear have how we can identify, how we can assign a product code to this. Look at that. First, the part is if rotational, then assign A. If not, then assign B. Further, in this case, this is rotational one, so we will assign A. In this, if round, then fine, assign 2, or if round with deviation, then assign 1. So here it is, we can assume that this is round but with a deviation. So we will assign 1 as a next code number. So now my part code become a A-1. Further, if regular or deviation, if non-regular or with deviation, or if a gear, so we can say that here it's a gear. So now my part code become A-1-1. Now, if external gear or internal gear, in this case, as you can see that this is the based on visual inspection, it's an external gear. So we can assign here now B as a code. So my new part code is a A-1-1 and B. Further, if spur gear, yes, it's a spur gear. So we will assign a 2. If bevel, we will assign here 1. So finally, the part code for this spur gear is A. A means rotational, 1 means with deviation. Further one is a gear. Fourth one B assigned for external, and 2 is for spur gear. So this is my part code. This is my part code. The hierarchical structure following one kind of hierarchy from top to bottom. With this, you can see that this is my hierarchy, and the code of a part is depend on my earlier criteria. Hierarchical structure have some key feature like provide large amount of information in a relatively small digit number. Then useful for storage and retrieval of the design related information such as part geometry, material, size, etc. And the drawback of this hierarchical structure is it does not provide us a manufacturing related any information. What kind of process is involved? What kind of manufacturing operation are involved? So that this is the main drawback of a hierarchical structure. The another kind of part coding structure is a chain type. In this, this is also known as polycode, in which the interpretation of each symbol in a sequence is always the same. Further, the value of each symbol does not depend upon the preceding value of symbol. Each digit in specific location of the code describes unique properties of that workpiece. It is easy to learn and useful in manufacturing situation where the manufacturing process has to be described. The length of polycode or chain type structure code may become excessive because it's a unlimited combinations features involved. Look at an example so you can understand easily in the next slide. For example, we are going to define 8-digit code to a part. The first digit belongs to material. The second digit belongs to material form, solid, liquid, etc. Third digit, material property. Fourth digit, bending method. Fifth digit, required tolerance. Sixth digit, level of surface finish. 7 digit, required testing method. And 8 digit, any other specific requirement like a heat treatment or color and so on. So this is the chain type structure coding system. For example, here image shows that the digit of codes from first place, second place, third place, fourth place. The class of feature are shown here regarding the external shape, internal shape, number of hole, type of hole, gear teeth and so on. The possible values for the external shape are 1, 2, 3, 4, 5, 6 maybe. At a first digit, it is cylindrical without deviation, cylindrical with deviation, box-like and so on. If internal shape, then center hole, blind hole, number of holes, then type of holes, gear teeth and so on. This kind of features are there. So if any part has number first digit is 2, it means that first digit is 2 cylindrical with deviation. The product is cylindrical with deviation. The second code is 3, it means that there is a second code is a 3, it means that there is a blind center hole. Third digit is 2, that means that there is a number of 1 or 2 holes in the object. Fourth digit are 1, it means that the hole type is the axial. Fifth digit is a 2, it means internal spur gear. So if the part has this kind of code, that is 23212, means we are going to have a kind of chain system that belongs to the cylindrical, to blind hole, to 1 to 2 hole, axial and spur gear. This is kind of chain is going to have the product, and that make a code for the product. Another kind of part code system is a mixture of hierarchical and chain type. So whatever kind of advantage are available in a hierarchical and a chain type are going to mix and uh, assign to code or product to code, and the system is known as hybrid system, and most coding system is in this the code structure. So let's summarize. Part classification based on design and manufacturing attribute we have seen. Further, we have seen that part coding and different three types part coding we have discussed. First one, hierarchical, chain and hybrid. In upcoming next lecture, I'll again describe the part coding basically that are following in the current scenario in the various company. So please do listen the next upcoming lecture. Thank you. Thank you for your kind attention and patiently listening the session. If you like, then share, comment, like, and press the bell icon so you will get the notification at the earliest. Thank you.